Every night, we look up at thousands of stars and naturally assume many of them must have planetary systems like our own. After all, if the laws of physics are the same everywhere, shouldn't the universe keep building copies of the solar system? For years, scientists believed exactly that. But as more than 5,000 planets beyond our solar system have been discovered, a surprising pattern has emerged. Instead of finding worlds that resemble our cosmic home, astronomers found something completely unexpected. The more planets they discovered, the stranger our own solar system began to look. If you've ever wondered whether Earth is just one ordinary planet in an ordinary planetary system, today's journey may completely change your perspective. We'll explore why our solar system appears unusually rare, what makes it different from most known planetary systems, and whether those differences could explain why life has managed to thrive here. The greatest surprise isn't that other planetary systems exist, it's that almost none of them look like ours. As scientists continue discovering new worlds, our solar system is becoming less like the rule and more like the exception. 1. The universe didn't build planetary systems the way we expected. When astronomers first began searching for planets around distant stars, they expected to find familiar patterns. Small rocky planets orbiting close to their stars. Large gas giants much farther away. Orderly orbits similar to those of Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Instead, they found chaos. One of the first major discoveries was a class of planets now called hot Jupiters. These enormous gas giants, sometimes larger than Jupiter itself, orbit astonishingly close to their parent stars. Some complete an entire orbit in only a few days, existing so close that their temperatures reach thousands of degrees. Nothing like this exists in our solar system. Then astronomers discovered planetary systems where giant planets followed extremely stretched elliptical orbits instead of the nearly circular paths we see around our sun. Others contained multiple massive planets packed tightly together. Some systems appeared to have planets constantly influencing each other's orbits in complex gravitational dances. With every new discovery, one conclusion became increasingly difficult to ignore. Our solar system wasn't typical. It was unusually calm. The planets follow remarkably stable, nearly circular orbits that have remained largely unchanged for billions of years. That long-term stability may have provided Earth with the consistent environment needed for complex life to evolve. In many other planetary systems, giant planets likely migrated inward after their formation, disrupting or even destroying smaller rocky worlds in the process. If Jupiter had done the same, Earth might never have existed. 2. Jupiter may have quietly protected life on Earth. When people think about Earth's survival, they often focus on our atmosphere or our distance from the Sun. But one of our greatest protectors may be a planet nearly 800 million kilometers away, Jupiter. Containing more than twice the mass of every other planet combined, Jupiter dominates the solar system gravitationally. Its immense gravity influences countless asteroids and comets traveling through interplanetary space. For decades, scientists have debated exactly how Jupiter affects Earth. While it can occasionally redirect objects toward the inner solar system, it also ejects enormous numbers of dangerous bodies completely out of the solar system, or traps them into stable orbits where they no longer threaten Earth. Without Jupiter's gravitational influence, impacts capable of disrupting life might have occurred far more frequently. Our solar system also benefits from another remarkable feature. The giant planets occupy the outer regions instead of crowding close to the Sun. That arrangement leaves the inner solar system relatively open, allowing the rocky planets to orbit peacefully for billions of years. Many exoplanet systems don't appear to have this luxury. There, giant planets dominate the inner regions, where habitable rocky worlds would normally form. Some researchers believe migrating gas giants may completely reshape developing planetary systems, scattering smaller planets into deep space or sending them crashing into their stars. In other words, the architecture of our solar system may not simply be unusual. It may have been essential. The stable arrangement we often take for granted could be one of the rare ingredients that allowed Earth to remain habitable long enough for intelligent life to emerge. And that's only the beginning, because when scientists examine Earth itself, they find an extraordinary collection of coincidences that becomes even harder to explain. Earth won the cosmic lottery again and again. Finding a planet at the right distance from its star is only the beginning. Earth possesses an extraordinary combination of conditions that scientists rarely see together. Our planet orbits inside the Sun's habitable zone, where temperatures allow liquid water to exist for billions of years. But that's only one piece of the puzzle. Earth also has a remarkably large moon. Its gravitational pull stabilizes our planet's axial tilt, helping maintain relatively stable seasons over immense spans of time. Without that stability, Earth's climate might swing dramatically, making the evolution of complex life far more difficult. Then, there's our magnetic field. Generated deep within Earth's molten core, it deflects much of the harmful charged radiation constantly streaming from the Sun. Without this invisible shield, the solar wind could gradually strip away our atmosphere, much like what happened to Mars. Even Earth's plate tectonics play a crucial role. The slow movement of continents continuously recycles carbon through the atmosphere and oceans, helping regulate global temperatures over millions of years. This natural thermostat has allowed Earth to remain habitable despite changes in the Sun's brightness throughout its history. Individually, none of these features seem impossible. Together, however, they create an incredibly rare combination. Many exoplanets discovered so far orbit red dwarf stars, which are smaller and more common than our Sun. While some lie within habitable zones, these stars often produce powerful flares capable of bombarding nearby planets with intense radiation. Other worlds may lack protective magnetic fields. Some may never have stable climates. Others could lose their atmospheres entirely. The farther scientists search, the more they realize that building a truly Earth-like world requires far more than simply placing a planet at the right distance from a star. 4. Does our uniqueness mean we're alone? At first glance, our solar system appears unusually fortunate. But does that automatically mean intelligent life is incredibly rare? Not necessarily. There's an important limitation to remember. Humanity has discovered only a tiny fraction of the planets that exist in our galaxy. Current detection methods naturally find large planets orbiting close to their stars because those are the easiest to observe. Planetary systems resembling our own may simply be harder to detect. Future observatories will almost certainly reveal many more Earth-sized planets in wider orbits. The universe may still contain countless systems remarkably similar to ours. On the other hand, if Earth's combination of stable orbits, giant protective planets, a large moon, a magnetic field, plate tectonics, and billions of years without catastrophic disruption truly is rare, then intelligent civilizations could be far less common than we hope. Either possibility is extraordinary. If Earth is rare, then life here becomes one of the universe's greatest treasures. If Earth-like worlds are common, then the galaxy may be filled with countless civilizations waiting to be discovered. For now, science simply doesn't know. Every new telescope, every newly discovered exoplanet, and every future mission brings us closer to answering one of humanity's oldest questions. How special is our home? Whether our solar system proves to be exceptionally rare or surprisingly ordinary, one fact remains unchanged. It has already produced a species capable of asking the question. And perhaps that, more than anything else, makes this tiny corner of the universe truly remarkable. For centuries, humanity believed our solar system represented the standard blueprint for planetary systems. Today, we're discovering that it may actually be one of the most unusual. Yet every new exoplanet we find teaches us something new about our own origins. Whether Earth is an incredibly rare oasis or one of many hidden among billions of stars, the search continues to reshape our understanding of life, the universe, and our place within it. Sometimes the greatest discovery isn't finding another Earth, it's realizing how extraordinary our own may already be.